What's up guys? Vasilis from Codings are here. This is the first lesson of the first course of the core pylon. So, it's the beginning, it's the most important course. Today we will be talking about the basics of programming. There should probably be something here, I hope there is. So, before we begin, I would like to ask you if that's not too much of a hassle to follow us on social media, Facebook, Twitter, YouTube, we also got Skype, Instagram, TikTok, we got a lot of stuff. So somewhere here would be our snap code. So we've got Snapchat, snap that, and follow us. So to begin our lesson, what is a computer? So in essence, a computer is a machine that can do a very big number of logical operations. What's a logical operation? It's, well, you can either compare two things to see if something is bigger than something, less than something, greater than, or you can also do arithmetic, like add stuff, subtract stuff. But the thing is that computers follow instructions. They're capable of doing and executing the instructions, but someone has to tell them what kind of instruction to do. This course and this whole pylon will introduce you to how you can teach a computer to understand your instructions and also execute them. So what comprises a computer? There are three kinds of stuff: input devices, output devices, and internal components. Input devices are devices that are used to input data into the computer. Such devices are your keyboard, your mouse, scanners, stuff like that, stuff that input stuff into your computer. And then there are output devices, like your screen, your printer, your speakers, all those kind of stuff are your output devices. And then there are the internal components. The internal components are like the CPU, the hard drive, your RAM or memory, whatever you prefer. And it would be essential to know how these work, how these operate, or what they do, at least at a very high level, to understand what they are. So the CPU is the powerhouse of the computer, like mitochondria are the powerhouse of the cell. The CPU is the powerhouse of the computer. It's the brains, it's what makes the computer understand and do instructions. It has minimal amounts of memory, which is, however, very fast, so it's only able to store like a couple of numbers. We're not talking about like the super modern CPUs which can save like up to 128 megabytes of data, but let's say that it's not, they don't have like big memory. It's like small, but it's really fast. Then there's the storage, your hard disk drive. Your hard disk drive is able to store vast amounts of stuff, up to terabytes or petabytes. I don't know, technology moves so fast forward that I don't know what's gonna be in like 2 years. For the moment, let's say it's terabytes. It can store a lot of stuff, but it's not that fast. Even your SSD is way slower than your RAM, and definitely more slower than the memory of your CPU. And then there is like the middle ground, the random access memory, or memory. So you will hear me in this course and generally in Quickiversity to refer to this as RAM or memory. So you better be on your toes, because I don't know which one I'm gonna be using, but probably one of those two. So the RAM is the middle ground between the CPU and the hard disk. It's not as fast as the CPU, but it's way faster than hard disk or your SSD. So when we want to load something that the CPU is gonna execute in the near future, we first load it from the hard disk to the RAM, and then from the RAM the CPU loads stuff to execute. So the comparison is that CPU, it should be like somewhere here, is the fastest but doesn't hold too much memory. Then there's like the RAM or memory, it's fast, it can store up to some gigabytes of memory. And then there's the hard disk drive, which is not that fast, it's kind of slow in comparison to the others, and typically goes up to some terabytes of data in PCs. Okay, so that's about the hardware, but I suppose you're here to learn about software. So, software. The computer hardware on its own is not very useful. It's able to do the calculations, but if there are no calculations to be made, it's gonna be sitting there and doing nothing. So software is the programs, is what feeds the CPU with operations, is the operations that the CPU gets. I'd like to split software in three parts. First is the BIOS. BIOS, or basic input-output system, if I'm not mistaken. But if I am, correct me. There are comments below, you can correct me. Yeah, right, it's up here, correct me. I'm wrong, yeah. It's the software that helps the computer to start up, to start loading the next piece of software we're going to be talking about, the operating system. So, the operating system. The operating system is what comes in the foreground after the BIOS has finished doing its stuff. It's responsible for managing all the system's resources, like the CPU, the RAM, the hard disk, everything. It goes through the operating system. And then there's other software. So, Doom, because there are other software, no, I'm kidding. So, our software is software that's created with specific purposes, like play a game, listen to music, browse the internet. It's software that runs on top of the operating systems most of the times, and uses the operating system to access the hardware to do stuff. So what is it that the computer understands? Somewhere around here there should be some blue numbers, zeros and ones, that you do not understand, but the computer does. So a computer only understands zeros and ones, power or no power, voltage or no voltage, true or false. It's the only thing that the computer understands on the lower level. So in one architecture, I think it's on MIPS, but I'm not sure. This operation, let's trust my notes, yeah, tells the computer to add the numbers in registers 1 and 2 and put the resulting number in register 6. So yeah, registers, if you see the really small note here, is one of the slots of the memory of the CPU, but this is not something you should be care of, because this will be taught in Systems 5, Introduction to Systems Architecture. So it's not really easy to give instructions to the computer like this, like zeros and ones. Some people do it because they're crazy, or because it's their job, or both. But it's not easy. What we want to do is to be able to provide the computer with instructions in a human-like language, which we will be calling a programming language from now on, which then will get translated at some point to zeros and ones, which the computer understands. The zeros and ones I mentioned earlier is called the binary system. It is a representation of numbers like decimals, 1, 2, 3, 4, 5, 6, 7, 9, then we go to 1, 0, 1, 1, 1, 2, 1, 3. Something like that, it's the decimal, but it doesn't go up to 9, it goes from 0 to 1 and then onwards. Each one of those 1 and O's is called a bit, and 8 of those 1 and O's, or 8 of those bits, is called a byte. When arranged in order, bits represent a number, usually. Each bit represents a sequential power of 2. Pause!
What is a power of 2? Some of you may not know what the power of 2 is.
So I think it's my duty to let you understand what the power of 2 is. So, let's say you have the number 2, right? That's 2 at the first power. Now let's say you have 2 multiplied by 2. That's 2 in the second power. Now let's say you have 2 multiplied by 2 multiplied by 2. That's 2 in the third power. And so on. I think you get it. The only exception I want you to know is that 2 in the 0 power equals to 1. When the resulting number of the power of 2 of all bits with value 1 is summed, we get the resulting number. Okay, this may be a bit confusing, because I probably didn't say it right, but in the next slide, you'll see that I have an optical example, which I hope helped you understand this a little bit better. So, on the top row, we've got the binary number, which we read from left to right, which is 1 0 0 1 0 1 1 0. Each of those represents a power of 2. If we start numbering from right to left, is it right? Yeah, right, left. Then we got 2 in the 0 power, 2 in the first power, the second, third, fourth, and so on. I will try now on the next row to show you what each of those powers of 2 means. So 2 in the 0 power is 1, 2 in the first power is 2, 2 in the second power is 4, and so on. 2 in the third 8, 2 in the fourth 16. So now, if we multiply each of those 1s with the corresponding power of 2, and each of those 0s with the corresponding power of 2, we get 1 multiplied by 2 on the power of 7, 0 multiplied by the power of 2 on the 6th power, 0 multiplied by 2 on the 5th power, and so on. Then all of these multiplications we add up, we get the sum. So we've got 1 multiplied by 2 on the 7th power plus 0 multiplied by 2 in the 6th power, blah, yada yada yada, which is translated to the sums which is below, which is 150 on our numeric system, the decimal. So now you know that 100101110 in binary is 150 on decimal. So I hope this wasn't too hard for you to understand. I really wish you that you will send all of your questions to this email, questions@codingjar.org, and I want to wish you all happy coding. Please, if you like this video, don't forget to add us on all those social media, Facebook, Twitter, YouTube, Skype, yeah, which all are by the username codingjar.org. Instagram, TikTok, which is really cool, you should follow us there, we do crazy stuff with the handle codingjar, and also our snap code somewhere here, I don't know, somewhere, snap this, and you add us on Snapchat as well. I was Vasilis from Codingjar, see you on the next lesson.